Hello, everybody. Today we're going to talk about power factor. We're going to talk about real power. We're going to talk about apparent power and reactive power. So here we have a beer. In this beer analogy, we're basically showing the beer itself is showing is a real power. It's the useful work in watts. And the reactive power is the form, is the wasted capacity in bars. And the whole thing is the apparent power, which is measured in VA. So, reactive power is required by many laws to provide magnetized current for motors, power transformers, welding machines, electric car furnaces, inductors, and lighting ballast. So the definition for a power factor is the ratio between real power and the apparent power of an electrical system. So real power, which is in the bottom right here, is measuring kW, and the apparent power is volt times amps, is measured in kVA, and reactive power is a magnetizing power and is measured in bars. So what is a bar? Active power, also called real power, is measured in watts or kW and performs useful work. Electrical equipment like motors and transformers require reactive power. It creates a magnetic field and allows work to be performed. This reactive power is called volt amperes or bars. Reactive power is measured in bars or kbars. The total apparent power is called volt amperes and is measured in VA or kVA. Here we have the three formulas. The first one is for real power, and the equation is square root of 3 times the line voltage times the line amperage times cosine of phi, which is your angle. Apparent power formulas. The apparent power formula is S equals square root 3 times the line voltage times your amperage. And your reactive power formula is Q equals square root 3 times the line voltage times the line amperage times sine phi. And the power factor formula is cosine of phi, which is your angle, and that based on the triangle that we have seen uh, before. So here's an example improving your power factor. So here we have a transformer or a capacitor bank, which shows a 125 horsepower. So you can also find if you, in order to determine your amperage, you can look at the NEC 2020 table 430.250, and you will find the full load amps based on a 460 voltage. So here we have the triangle in here, which is your apparent power is 125 kVA equals square root of 75 bar plus 100 kilowatts. So that's your apparent power. But in order to find your 125 kVA, there's different ways that you can find it as well as 75 k bar. So let's say we have, in order to find it, let's go back to and use the formula that we saw before, which is your square root of 3. We're going to find the 125 kVA. You can find that by multiply square root of 3 times 480 times 150 times cosine of zero point 0.8, which is your power factor. Uh, that will give you 124,694, which is basically 125 kVA. And you can also find 75 kVAR, but in this case you have to find the new angle, the new V, the angle for sine. So you will take the inverse of that angle, that zero point 0.8, and it will be 36.86. So you will multiply square root of 3 times 480 times sine of 36.86. That will give you 74,960. That's about 75 kVAR. So in order to improve your power factor, we added a 50 kVAR bank capacitor. Okay, so in that case, as you can see here, 75 minus 25, you added 50, then we will we have 124 amps, 103 kVA, 25 kVAR, and you will do the same in order to calculate for, let's say, the kVA. So kVA will be square root of 3 times 480 times, which is your power factor, cosine of 0.97. So that will give you about 103,060 kVA. So it's approximately 103. So now you will do the same thing uh, to find the 25 kVR, but in that case we will have to do the inverse of cosine of 0.97, and that will give you 14.06, and you will have to multiply square root 3 times 480 square root 3 times 480 times 124 times sine of 14.069. That will give you 25,061 uh, kVAR. So that's how you also find by taking the formulas in order to determine the reactive power, the apparent power, and the real power for in order to determine the power factor if you want to improve it. So here we have the Ohm's law that will help you in order to that will help you do some calculations, and it's very useful because power factor um, is used in industrial and commercial places in order to reduce the electric bills, and help reduce the cost in order to save some money. And it's good because initially you're investing in order to save in the long run, depending how many motors or how many furnaces or whatever you have in the industrial facility. That way, you'll be saving money as well. Well, this is all, and thank you.